Hey friends, welcome to NIKRA'S Expert Learning. In today's video, we are talking about the types of bolts used in the bolted connections. So this is a very important topic, the bolted connections in the steel structures. So this is a new series of steel structures wherein we are in the third video discussing the types of bolts in the bolted connections. If you find this video helpful or you got to learn something from this video, please do subscribe to the channel guys, that would greatly motivate me. Coming to the topic, types of bolts. First one, we are having unfinished bolts or bearing bolts or ordinary bolts, common bolts, black, rough, slip type, non-friction type. So with whatever the name you call, the unfinished bolts or the common bolts which we are using are the bearing bolts. Okay, the ordinary bolts we are using. They are non-friction type, slip type. Okay. This is the first classification. Okay, the first type of bolt is this one, the ordinary one which we are using. This fails by shear and bolting. So for static loads, generally we are using this unfinished bolts. Okay. So here the load transfer from bolts to be in between the plates. So generally these are used for light structures subject to static loads. So static loads are with respect to time which we don't change. Like the moving loads is in the case of bridges, we are having vehicles moving over that, wherein we are seeing the movement that is changing with respect to time. So the static loads are something which don't change with respect to time. Okay, and for secondary members such as purlins, bracings, etc. So the primary load resisting members, these are not recommended. So the secondary members wherein the load should be taken is very less, and its placing is also like secondary member. They are not recommended for connections subject to impact loads, vibrations and fatigue. So whenever I am telling you impact loads, remember the load that acts from certain height. Okay, so if this is a member and the load is acting from this height, it is dropped from this height. So from certain height, if the load is acting, we are calling it as impact load. We know the vibration. What is fatigue is the repetitive loads. The bridges, on the bridges, whatever the vehicular loads we are getting, they are repetitive loads. That is fatigue. Okay. These bolts are made from low carbon steel, and that is why to resist all these loads, we are not recommending this. For the impact loads, vibrations and fatigue, we will go with the secondary bolt. That the second bolt, that is a Hsfg bolt. Okay, which I will be explaining you in the next case. So in this, the low carbon steel is used. Low carbon steel circular rods are used to make these bolts. Okay, so depending upon the carbon percentage, the classification has been done over here. The cast iron, wrought iron, the steel. So depending upon the carbon content, we can see the types of the materials formed. So here whatever the changing is the carbon content. That's the variable over here. Next, oversized holes should not be used for bearing connections. Bolts are tightened with snug tight spud wrench. Okay, here the wrench is fixed. This is an ordinary bolt. So that is why here the oversized holes, that is to the bolt, the hole that is made should not be of greater size. Okay, the hole should be such that the bolt just fits in. Okay, and here we are using snug tight spud wrench, the wrench that is used to tighten the nut. Okay, to fix the nut in its place, we are using these wrenches. Next, square heads cost less, but hexagonal heads give a better appearance and are easier to hold by wrenches and require less turning space. So depending on our requirement, we can choose one from the square and hexagonal one. Generally hexagonal is preferred more because aesthetically we get a better view, and also we think that hexagonal are better to take the loads. Okay, their resistance is greater. And here the bolts are available from 5 to 36 mm diameter. That is, whenever I am telling you the diameter, remember that is the shank diameter. You know what is shank and threaded region? So to the bolts, this is the diagram, right? See, this is the bolt diagram. So wherein this is the threaded portion, this is the shank region. This is the bolt head. Okay, so whenever I am telling you the diameter, remember this diameter I am mentioning. Okay, this is the shank diameter and designated as M5 and M36. So here 5 represents the diameter, the shank diameter. However, in structural steel work, the most common ones are M60, M20, M24 and M30. IS 800 2007. So this is the code book from which we get the recommendations for the steel structures. Stipulates that the net tensile area of the bolt to be considered is the ratio of the area at the root of the threads to the nominal planned shank area. So depending upon the IS codal provisions, this is the recommendation. Okay, the IS codal provision, the IS 800 2007 stipulates that this is the formula. That is, I told you this is the shank diameter, but we also have the threaded diameter. So for this one area is there and this is the other area. So the threaded area, this is the shank area. So the ratio of the threaded area to the shank area is 0.78. This is as per the IS code 800. Okay, the A and B divided by ASP is 0.78. This is the threading area and this is the shank area. Okay, so here we are also specifying the grade of the bolt. So what is the grade of bolt is? Grade of bolt nothing but the bolts of property class. So this is the class are available of which most commonly used bolts are of property class 4.6 and 8.8. So here we are specifying the grade. Like in the concrete we will be mentioning M15, M20. So that is we are mentioning the grades. So here the concrete grades are mentioned over there. But here in this case we are mentioning the grade of bolt. Okay. Next we are having the second type of bolt, that is Hsfg, the high strength friction grip bolt. Okay, the first one is the ordinary bolt, non-friction type bolt, the slip type bolt. Okay, but the second one we are having is the Hsfg bolt. Here Hsfg is high strength friction grip, Hsfg. Okay, and these are used for the dynamic loads. They fail by friction. Here the load transfer from bolts directly to plates through friction. So here the load transfer mechanism is friction. So in the previous video, depending upon the load transfer mechanism and the load transfer the resultant forces location, I have explained you what all the different types of connections we are having. Okay, the types of classification of the bolted connections and the bolted connection in detail, wherein we have studied what is a bolt, what is a bolted connection, and what all different types of the bolted connections we are having. If you haven't watched that video, please go check out in my channel. In the playlist of the steel structures, I have provided that video. That is the second video I have made, and this is the third one. So the HSFG bolts are non-slip bolts, critical bolts. Okay, these bolts are made from bars of medium carbon heat treated steel from alloy steel. Okay, remember, and from alloy steel. So we are using the medium carbon steel, medium carbon heat treated steel, and from the alloy steel. The combination of both, we are using this HSFG bolts. Okay, so these bolts may be tightened until they have very high tensile stresses. So until we are ensuring that our tensile stress is up to the maximum limit, we can tighten it. Okay, so wherein the normal bolts, if we tighten much, there's a chance of failure of the bolts. But here we don't see that. So until the tensile stresses are at the higher limit, we can go with the tightening part. And remember, the HSFG bolts transfer the loads primarily by friction, not by shear. Hence there won't be any slip. Hence these joints are known as friction type non-slip or slip critical bolts. So this is the joint. See, this is the HSFG bolt. HSFG bolts are available in sizes 16 to 36 mm and are designated as M16, M20, M24 and M30. So here the class is identification symbol set as 8S, 8.8S, 10S. So embossed on the head of the bolt. So here on the head we can see the which class, the class identification symbol, that is the which class it belongs to. Okay, and here the S is nothing but the high strength. So whenever there is some notification regarding this 8S, the S represents high strength. These HSFG bolts are tightened either by part turning or turn off nut method or torque control method by using a load indicator washers. So depending on the requirement or the availability, we'll be selecting one method to tighten this HSFG bolts. So just by using some wrench you cannot tighten this. We have some methods, we have some techniques or instruments to turn this, to tighten the HSFG bolts. So depending on our availability, we'll be selecting one. So generally we are having two types of bolts. First one is the ordinary bolt and second is the HSFG bolt. So during the construction of bridges or dam or the steel structures, we go with this HSFG bolts for the primary members and for the dynamic loads. But whenever we have to go for this secondary members where that have to be taken care of only the static loads, we'll be going with the ordinary bolts. Okay, that is it for this video, guys. If you like this video, please like, share and comment the channel, and don't forget to subscribe to my channel, guys. That would greatly motivate me. I appreciate you watching this video, guys. Thank you.